What's up, it's Nitin from acentasecond, and today we will be discussing what a partial derivative is and what do they actually mean. So here I have a function of three variables, and it looks very sophisticated at first. Finding a derivative might be a little difficult if you don't know how to find a derivative. What a derivative actually means, and a partial derivative in that case, is that you keep one variable constant or more than one variable constant and find a slope according to one of the other variables. So that's a very general description, but if you need a more specific response, let's do this. So let's say I want to find a derivative, and so a partial derivative, you use this symbol. A derivative of a single variable, you just use a regular d. And so a partial derivative, so here in this case we have a three variable function, and a partial, let's say we can pick any variable we want. So we can pick the variable of x. And so the variable of x here, we find the partial derivative. That means wherever there's an x, that's where I'll differentiate. If there's not an x, that means it's just a constant. So it's like a number. So in this case, 5x, y. 5y would be our constant in this case. So 5y, and the derivative of 5yx would just be 5y. How did I get that? So it's like taking the derivative of each term. So d dx of 5yx. No, I rearranged this according to putting everything on the left that's not an x and putting everything on the right that's an x. So any standard derivative, so if we take a step back, d dx of 2x, we all know that's just 2. What did we do? We did minus 1, so we did 2 times 1, so we brought the exponent front, and we minus 1 from the exponent. So that's 2 times 1, which is 2, and then 2, and then x to 0, which is just 1, that's just 2. So that's how we got this 2. We can apply the same logic to this thing, this 5yx, and so this x term essentially goes away, and we have this constant left, 5y. And that's how we get this 5y. Now, how about this negative 8yz squared? What did I say? If there's not an x, we treat it as a constant. So that means the derivative of a constant is just 0. And so the partial derivative with respect to x is just 5y. So that means the slope, if we keep everything constant except for x, is 5y. So that means the slope of x is dependent on y. Now, what if we want to take a derivative with 2 variables, or even 3 variables, which we can do since we have all those variables present? And what if we don't have that variable? How do we take a derivative then? So let's figure it out. So let's say I want to take a derivative of two variables, so dy dx. So I take the derivative of the function. Either you can put f or you can put all 3 variables, it's up to you. And we could do, I said dy dx. Note, the way you take a derivative may matter depending on the order. Sometimes it doesn't, usually it doesn't, but sometimes it can, depending on the function. You go from right to left, so you start with using a derivative on the function with respect to x, then with y. And so the way this would work, we use this notation, a partial derivative according to y, and then this partial derivative according to x. Very fancy notation for something that just means take a derivative twice according to 2 different variables. So we take a derivative according to x first, so that means this derivative, so this partial derivative according to x would just be, we did it earlier, it would just be 5y. Pretty simple. Now, let's take a derivative according to y. So now we're taking the partial derivative according to y of 5y. Well, our function only has y's in it with a constant, but that just means we're just taking a standard derivative according to y. So the derivative of 5y with respect to y is just 5. So that means that the derivative, if I keep z constant, of x and y is just 5. Which makes sense, because the partial derivative according to x is 5y. If I take a derivative according to y, I'll get 5. That means the slope of x and y as a function is 5. That makes total sense. And that's how you take partial derivatives. Now, what if I have all three? Then I can just, what I can do is just add it on here. Or add it on in the beginning, depending on whatever order they give it to you in. And so let's try that one now. So you can do single derivatives, you can do double derivatives on either side. You will get different answers. So now we know, so our a partial derivative of our function, so let's do dz, dy, and dx. So that just means we're taking this derivative first, then this, and then this. We already know that dy or dx and dy give us 5. So that means we're just taking the partial derivative of dz of 5. And the derivative of a constant is just 0. So that's how you find the derivative, a partial derivative in that case, for 3 variables. You can do it for 2, you can do it for 4. It just gets more complicated as you have more variables. In my opinion, differentiating with more variables is easier than integrating with more variables. If you do need help with that, let me know down in the description or in the comments. Hit me up. My links are below. I charge a cent a second. Feel free to hit me up. Peace.